Hello everyone, this is Chapter 19, Lecture 1. And in this chapter we're going to talk about the demand for money. Now, modeling the demand for money is a big topic that really has never really been resolved in macroeconomic theory. So what I'm going to present is a few different approaches that have been attempted over the years. We'll talk a little bit about what works with them, what doesn't work with them. And we're going to start with a very, very early theory called the quantity theory of money. And this goes back to the beginning of the 20th century. So this is rooted in what we call classical macroeconomics. And the quantity theory essentially was a theory about how the nominal value of aggregate income is determined. In other words, what we want to do is we want to know what that price level is. So how do we change, the real kinds of goods into, well, whatever they were nominally valued at, or valued without adjustment for inflation at the particular time, or valued in current dollars. But when we take this and impose a few assumptions on this idea of the quantity theory, we can get a rudimentary demand for money. So it really starts out with this concept called velocity. So the velocity of money is essentially what we will think of as the turnover rate of money, or it's the average number of times in a given period that the average dollar changes hands, or the average unit of currency changes hands, or is used. So the thing you have to remember about money is when you spend a dollar, well, it's gone. So it seems like, well, it doesn't exist anymore. But actually it does, because it gets transferred to the person whom you gave it to when you spent that dollar. So that dollar can then be reused. That person who received it can then spend it, and so on and so forth. So $1 might be spent more than one time within a period, meaning that with a particular money stock, we could have more than that amount of money in the money stock in terms of transactions. And so that's what we mean by this velocity. If you're familiar with accounting, you might think of something like inventory turnover rate. It's a similar concept. You never actually fully sell out of your inventory, but how many times would you have sold out if you had to sell it all and then reorder? Kind of thing. It's a similar concept, but we should think of it as a turnover rate. And so by definition, the velocity is equal to nominal income. Now notice on top here, what do we have? We have this nominal income, or P times Y, which is Y is our real output, or real GDP, and P is price level. So it's basically price times quantity gives us nominal GDP, or we'll say nominal GDP, over the money stock. Now there's something to be noted here. Notice that this is a funky equal sign, that this is this 3-bar equal sign. Well, that means that this is an identity, right? What is an identity? An identity is something that's true by definition. So if you look at a dictionary is the identities of all these different words, all right? That's their definition. I don't have to prove that velocity equals nominal income or nominal GDP divided by the money stock. I don't have to prove that at all, because it's just true by definition. That's how I've defined V. V's definition is this. So that's what we mean by this being a identity. If I move this around just a little bit, in other words, I'm going to multiply both sides by m, I end up with something called the equation of exchange. Now, within the equation of exchange, this has a really interesting interpretation. I can look at m times v. The equation of exchange has a particular interpretation, and it's kind of nice. I can look at this one side, this m times v. The number of dollars in the economy times the number of times each dollar gets spent on average during a given period. Well, what's that? That's money spent. On the other hand, P times Y is, well, nominal income. Well, income is received, so really this is money received. So it has this nice interpretation of being the fact that we have money spent, so for every dollar that gets spent, somebody had to receive that dollar as income. So money spent equals money received. And essentially we're going to call this a truism, or a tautology is the technical term for that. It's true by definition. So continuing on just a little bit with this quantity theory, we're going to impose a few assumptions. So far, all we have is an identity. Right? It's true by definition, which the nice thing about that is you can't really argue with it, but on the other hand, it's not very useful. So let's keep going and let's impose a few assumptions. The first assumption that we're going to impose upon this, now, one thing you have to remember is this theory is coming around 1900, between 1900 and 1920. During that time, we didn't have computers, we didn't have the internet, we didn't have the ability to do the kinds of data and empirical analysis that we can today. And so, as a result, they thought velocity was pretty well constant. Velocity was constant. Why would they think velocity was constant? Well, because what would change the number of times you are able to spend $1 on average in a period? Well, really, the only thing they could think of that would do that would be technology of money. So it makes it easier to transform money. So examples of technology of money were the development of moving beyond gold to a representative money, using a piece of paper to represent gold or some other commodity. Made it much easier to transfer it, and so you could spend more. It's faster. A more modern example would be electronic banking. All right, and online banking. These are all more modern examples. Obviously, that was not even a thought in 1900, so they thought the velocity was pretty constant. They also didn't really have any data to check that. 2, when we impose this constancy of velocity, this equation of exchange kind of ceases to be an identity. It starts to, we're going to have a theory, and this is the governing equation of that theory. But it's true, but only if we assume velocity is constant. So we start to become a little weaker, right? But a little more useful at the same time. Next, nominal income essentially is determined by the total money stock, right? How do we get that? Well, essentially, they assume 2 things. Number 1, velocity was constant. And number 2, Y, output, grew at a constant rate. Okay? We have constant growth of Y and constant velocity. So if I think about that, and I write this equation of exchange back down again, what do I end up with? I have M times V, but V is constant, so it's not changing at all, equals P times Y. But Y is growing at this constant rate, so I'm not sure how to write that. Maybe I'll put a little squiggle or something above it, indicating, hey, it was growing at a constant rate, but in any event, it's fixed. It's not being determined by any of this. It just is what it is. So if M goes up, can V change? No, it's constant. Can Y change? No, it's growing at this constant rate. So what has to happen? P has to go up, and vice versa. So essentially, we can see that, well, if V is constant, the only thing on the left-hand side of this equation to change is M. And so any change that happens in nominal income has to be attributable back to M. And if we add in this extra assumption that Y grows at a constant rate, we can say, well, there's the direct relationship here between M and price level. Like they said, the classicals assume that Y, not that Y was fairly constant. This isn't quite right, but that its growth, Y's growth, is fairly constant. So essentially, we can get at this last point. Price is determined by money growth, or the total money stock. All right, and now we're going to come back to that subject in a minute, but essentially what this gives us here is a nice linkage or theoretical foundation for a linkage. Now, maybe it's a little more complicated in the real world, but this gives us a very nice linkage between the money stock and price level and how price level is determined. So let's put this and try to figure out a money demand equation. Well, if we simply solve that equation of exchange, and notice I've removed the triple equal sign there, the identity sign, for an equal sign, because really we're imposing that identity plus all these other assumptions that I have here. And we end up with a function that has money is a function of the velocity, price level, and output. But let's remember, velocity is supposed to be constant, and Y's growth is constant. So what do we have? As price level increases, what happens? Our demand for the money stock increases. And as price level decreases, our demand for money would then decrease. And so we have a very, very basic demand for money function. We can rewrite this a little more neatly by replacing the big money stock with a money demand function. All right, so that's quantity demanded of money, and then replace the 1 over V with a little k. And the reason why we do that is to indicate that, well, that just really makes it clear that this velocity is a constant, right? That this is just a constant. But there's a pretty big goofiness factor about this particular money demand function, and that is there is no interest rate in it. In other words, there's really no price of money in the money demand function. In other words, we have a demand for a good, all right, with which price of that good isn't a factor of demand. And so really, if we think about it, that just seems a little weird. Usually we think of demand being price and quantity demanded. But here we have quantity demanded but no price. But you're saying, well, wait a minute. There's a price. There's this P. What's this P guy right here? That's not the price of money. That's the overall price level. Right? So that's overall price level of aggregate goods. If we take the growth rate of that P, we get the overall inflation rate, not the price of holding these monetary assets. So here's the big problem with this. It's strong in that it's based on essentially an identity. So it has a very, very strong theoretical foundation, but it leads to an implication that seems a little bit weird, that the interest rate, that a particular interest rate has no effect on demand for money. And that seems wrong. On top of all of that, we also have a couple of other assumptions we need to check. We need to say, is velocity constant? So this is a big question. Is velocity constant? Because if it's not, then that formulation, while might be reasonable, the implication that interest rates make no difference to demand for money becomes much less reasonable, because we could see possibly how interest rates might affect velocity. And to see that, we're going to wait just a second for a couple of slides. But we need to ask this question. The classicals thought velocity was constant because they didn't have good data. After the Great Depression, economists realized, well, the velocity wasn't really constant. And so here we have a plot of velocity. This is not my favorite. These are not my two favorite measures of money, but they do get at the idea. If you measure money a little more proper, a little more appropriately, then this velocity is a little less volatile, but there's still the point blank, the basic thought process here is velocity is not constant. We can see it's constantly changing. This is the growth rate. It's constantly going up and down, and if we were going to see velocity be constant, what we would expect is to see just a straight line right across zero. All right, why? Because this is the percent change in velocity. So it's a growth rate. And we would expect no change if it were constant. Well, clearly we're a long ways from no change.